This is the continuation of my last class. This problem is yet to be done, and I have taken one more problem in finding the rank of the matrix. This is the problem, and as I have explained already that you go for all row and column operations and try to bring it to a form as like this, IR 0 0, something like this, or IR 0. This IR is nothing but the unit matrix of order R, so that you can say that the rank of the given matrix is R. That is the way you have to do. But I told you that the other way of doing is you bring this to an upper triangular matrix, and the upper triangular, after bringing it to upper triangular matrix form, you can very well decide the rank of the matrix by counting the number of non-zero rows. Now that's what I am going to do in this problem. Now you see that here, what is that you will do? See here, I will do this. So this is nothing but, I will write this as 1 minus 1 minus 2 minus 4. That means what? I am taking second row to the first row and first row to the second row, or 3 minus 1 minus 1, 3 1 3 minus 2, and this is 6 3 0 minus 7. So you see that this R1, see what is that I have written here? R1 and R2 interchange their places. R1 and R2, here if I put the two-way arrow, it means that what? They interchange their places. So R1 and R2, R1 comes to R2, R2 comes to R1 position. Now you see that here, then I will write this as, here you see that what I am going to do is retain the first row as it is, minus 1 minus 2 minus 4. Then this is R1, then R2 minus 2R1. Multiply the first row by 2 and subtract it from the second row corresponding elements. So 2 into 1 is 2, 2 minus 2 is 0. Bring A11. What I mean is that this is A11, make it as 1 and bring the elements below them as zeros. Then you keep it as A2, this is A22, bring all the elements below as zeros. And this is A33, bring all your elements below them as 0. So you will get what? The zeros here and non-zeros here, and this will be a what? Upper triangular matrix. If you bring it to this form, it may not be necessary for you to bring it to that unit matrix, reducing it to unit matrix form. So this is what I am going to do here. So you see that this is 2 minus, and 2 into minus 1 is minus 2, and 3, see what will happen? 2 into, you subtract from this, see, 2. 3 into 2 into minus 1 is minus 2, subtract means you will get it as 5. Then 2 into minus 2 is minus 4, you subtract, it will become plus 4, so it is 3. 2 into minus 4 is minus 8, then you subtract, so it will become plus 8, it is plus 7. Then R3, here 3, I must get rid of this 3, so 3R1. So 3 into 1, 3, 3 minus 3 is 0. 3 into minus 1 is minus 3, you subtract from 1, so it will become what? Plus 3, it will be plus 4. Then 3 into 1, 3 minus 3, 3 into minus 1, 4. 3 into minus 2 is minus 6. If you subtract, it will become plus 6, it will be 9. Then 3 into minus 4 is minus 12. You subtract, you will get plus 12, so it will be plus 10. Then R4 minus 6 R1. Get rid of this 6. So 6 into 1 is 6, 6 take away 6 is 0. Then 6 into minus 1 is 6, minus 6. Take away means what? 3 plus 6 is 9. Then 6 into minus 2 is minus 12. Take away from this, it is 12. Then 6 into minus 4 is minus 24. Take away is plus 24. So this will be 17. So you see that I am able to get below A11 all zeros here. Now A22 here bring 0 and A33 here make this 0. So if you can successfully bring it to that form, upper triangular matrix, then you can very well decide the rank of the matrix. Now I will go for further operations here. So this will be, see what is that I can do here. So 5, 3, 7. So I will divide this toward by 5. So what is that you will get? 1 minus 1 minus 2. Then it is minus 4. Then it is 0, 1, 3 by 5, 7 by 5, or 2 divided by 5 or 1. Then this is 0, 4, 9, 10, 0, 9, 12 and 17. So this is what you get. Then what is that I do afterwards? So I am getting here 1. See, I am able to bring this A22 as 1. Can you just observe? Here I have got A22. Now it is easy for me to get 2 zeros down. How will you do that? So you see that here I will write 1 minus 1 minus 2 minus 4. 0, 1, 3 by 5, 7 by 5. R1 is there, R2 is there, R3 minus 4 R2. So multiply this by 4, subtract from the 4. Can you understand? So this is 0. 4 into 4 is 4, 4 minus 4 is 0. Then 4 into 3 by 5 is 12 by 5. Take away from this 9. So 45 minus 12 will be what? 33 by 5. 3 to 5, this is 33 by 5. Then 4 into 7 is 28 by 5. Then 10 minus this will be what? 50 minus 28 will be what? 22. So this is 22 by 5. Then what is the next one that you will do now? So you can get rid of this, multiply this, see, R4 minus R2, 9 R2. So 9 into 1 is 9, 9 minus 1 is 0. Then 9 into 3 is 27 by 5. Take away from this. This is 60. 60 minus 27 is 33. 33 by 5. Then 9 into 7 is 63 by 5. Take away from 17. So this is 85. 63 means what? 22. So 22 by 5. So I am able to get this result. Then this is also equivalent to 1 minus 1 minus 2 minus 4 0 5 3 7. This is R1 5 R2 multiply throw it by 5. Then third one is R3 into 5 by 11. Multiply R3 by 5 and divide it by 11. So what is that you will get? 0, 0, 3, 2. This is your R2. Then R4 into 5 by 11. R4 into 5 by 11. So this will be 0. This will be 0. Multiply this by 5. 5 and 5 will go off. Divide it by 11. So you will get 3 and 2. So this is what you will get. Then next step is, so this will be 1 minus 1 minus 2 minus 4. 0, 5, 3, 7. Then you see that I go for this, that is R1 I am keeping it is, R2 I am keeping as it is, and you see that 0, 0, 3, 2, and you go for what? R3, and you write it as what? R4 minus R3. R4 minus R3 will be 0, 0, 0. Now you see that this is what you get. And you will find that you just try, you will find that it will not be easy to bring here a 0. It is not possible. See, this is your upper triangular matrix. Can you see this here? 1, 5, 3, 0. And below this, you have got all zeros. And above that, you have got all numbers. When you have successfully brought like this, you can decide the rank of the matrix. What is that I told you? The rank of the matrix now is nothing but the number of non-zero rows. Now you see that this is the only 0 row. Can you see this? So what is that? 1, 2, 3, 4. 4 rows are there, out of which only one is 0. Zeros. That row is fully 0. Therefore, your rank of the matrix A is equal to 3. Can you understand? So how do you get this 3? The 3 is nothing but what? How do you get this 3 is that you bring it to your upper triangular matrix, even lower triangular matrix you can do. So you see that this is an upper triangular matrix, and after bringing successfully this upper triangular matrix, you can count the number of rows which are non-zeros and say that the rank of the matrix is the number of non-zero rows. Here the number of non-zero rows is 3, and therefore the rank of the matrix is 3. Okay, so this is all about this. Now coming to this next problem, I will find the rank of the matrix and simultaneously solve. See, solving this will be, first method is that, see, we can use one. See, it is like this. First method is you take like this 5, 3, 7, and it is 3, 26, 2, and it is 7, 2, 11. This multiplied by x, y, z is equal to your 4, 9, 5. So this is what you get. So this is nothing but ax is equal to b. This implies x is equal to a minus 1 of b. This is one method. That means what? You find the inverse of this matrix and multiply it with b, and you will get the solution for x, y, and z. This is method 1. Second method is your x value can be got by using Cramer's rule. What is that? If you are going to find the value of x, 4, 9, 5, then 3, 26, 2, then 7, 2, 11. This divided by the determinant of the matrix A. And what is y similarly? Y will be equal to, in the place of y column, you must put what? The constants on the right hand side. That is 5, 3, 7, and 4, 9. This is your y place. And what is the next one? 7, 2, 11. This one divided by determinant of the matrix. Likewise, what is your z? Z will be equal to your 5, 3, 7, 3, 26, 2, and in the z column you can put what? 4, 9, 5, and this is divided by determinant of A. This will all give you the solution for the thing. So you have to find the determinant value of this, then determinant value of this, but divide, and likewise if you do, you will get this is called Cramer's rule. This is called your Cramer's rule. Now using the Cramer's rule you can find. Next method what I am going to teach you is finding the rank and simultaneously solving the equations. What is that I am going to do? Finding the rank of the matrix using that upper triangular method and simultaneously solving the equation. That's what I am going to teach you today. Now here what I will do here is, see what is that you will do now? See what is your augmented matrix? Augmented matrix, this is A, this is your X, this is your B. Now what is your augmented matrix? Augmented matrix is this is 5, 3, 7, 4, 3, 26, 2, 3, 26, 2, and it is 9. And it is 7, 2, 11, and it is 5. This is called your augmented matrix. Now let me find the rank of the matrix and simultaneously solve. We will solve it, okay? Now, so this can be written as, I will write it here. It is 1, 3 by 5, 7 by 5, 4 by 5. So R1 divided by 5. 3, 26, 2, 9, 7, 2, 11, 5. Okay? Now this is what you get. That means what? As I told you, this is your A11 place. Bring below A11 all zeros. This is your A22 place. Bring below A22 zeros. A33, like that you must go. So it will become a triangular upper triangular matrix. So what is that you will get here now? So I will go for this. So this will be 1, 3 by 5, 7 by 5, 4 by 5. Multiply this by 3. See, this is R1. Then R2 minus 3R1. Multiply by this by 3 and subtract. You will get 0. Multiply this by what? 9 by 5. Then you go for 36. So you will get 121 by 5. So you simplify, you will get 121 by 5. Then multiply this by 3. So it is 21 by 5. And you subtract it from so. So it is 10 means what? Minus 11 by 5. Then what is the next one? So this is, multiply this by this, that is 12. It is 12 by 5. Then you take away from this is 45, 33. So this is your second row. Then the third row is R3 minus 7 into R1. 7. See, 7 ones are 7. Take away this, you will get below A11 0 elements. So what is that you will get here? 0. Then 7 into 3 by 5 is 21 by 5. See, 7 into 3 by 5 is 21 by 5. Take away from this 2. So it is 10. It is minus 11 by 5. Then go to the next one. 7 sevens are 49. 49 by 5. Take away from this 11. So it is 55. 55 minus 46 is what? It is 55, 6. So it is 6 by 5. Then it is 7 into 4 is what? 28 by 5. 5 minus this. So 20 is minus 3 by 5. So this is what you will get. So this is what you get after doing some column and row operations. Then we will come to this. See, Actually, this is easy way of doing it. It is less laborious than using the first method. I gave you two methods. This method is less laborious than the previous two methods that I have given. Now you will find it easy now. Now what is that you will do now here? So after finding this, so this can be written as, see, 1 multiply this by throw out by 5. So we will get what? 1, 3, 5, sorry, 5, 3, 7 and 4, or 1 multiplied by 5. So if you throw out multiplied by 5, you will get what? This one. Then the second one is R2, you multiply it by 5 and divide it by 11. So what is that you will get here? 0. If you multiply it by 5, 5 and 5 will go off. Divided by 11 means it is 11. This one, if you do, 5 and 5 will go off, 11 and 11 will go off, giving you -1. Here 5 and 5 will go off, 11 by 33 by 11 will be 3. Then the next one is, so next is R3 into, you will get it as into 5. So multiply this by 5, it will be 0. Multiply by this by 5, it is -11. Multiply this by 5, you will get 6. Multiply this by 5, we will get -3. So this is what you get here. Then what is that you will do? And I told you that below A11, bring A11 is this element. This is your A11. Bring A11 below A11 all zeros. Here A22, bring below A22 all zeros. A33, bring. So that is the way we form the upper triangular matrix. Okay. Now, so what is that you get now here? So what is that you will get here? So this is 5, 3, 7, 4. You retain it as it is. Then 0, 11, -1 and 3. This is your R2. Then I will write this R3 minus R2. What is that I will do? R3 minus R3 plus R2. R3 plus R2. So 0 plus 0 is 0. Plus 11 minus 11, when you add, it is 0. It is plus 6 minus 1 will be what? Your 5. Plus 3 minus 3 will be what? Your 0. So this is what you get. Now you see that I am able to bring it to a successfully as what? This one. I am this form. Now you see that further if you try, you cannot make this 5 as zeros. I will tell you, it is not possible. You try in any way, you will not get. That means what? Here the rank of, see, rank of AB. What is the rank of AB? This is your AB. Rank of AB is equal to 3. Up to this, your rank is your A. So rank of A is also equal to 3. That means, how do you say that rank of A is equal to 3? How many? See, you take only this. This is your A matrix. So rank of A is what? The number of non-zero rows. This is a non-zero row because 5 is here. This is a non-zero row. This is a non-zero row. Therefore, rank of A is 3. Here you see that AB, if you take the augmented matrix, here this is a what? This first row is non-zero. Second row is non-zero. Third row is again non-zero. That means what? Row of A is 3. Row of AB is also equal to 3. And what is the n? Is it A3 is equal to n, the number of unknowns. Correct or not? Unknowns. Now, what does the rule say? If the rank of the matrix A is equal to rank of the augmented matrix and is also equal to the number of unknowns, here you see that the rank of A is 3, the rank of AB is 3 and the number of unknowns also equal to 3. Then the rule says that X, Y, Z or the unknowns will have unique solution. Are you able to understand? Now let us see whether we are getting unique solution. I will take one more problem on a different problem, in the sense that where you can get in infinite number of solutions. I will take on some other day how do you an example for infinite number of solutions. But in this particular case, it abides the rule, in the sense that it abides by the rule that if row of A is equal to 3 and row of AB is also equal to 3, augmented matrix, and is also equal to the number of unknowns in that, then the solutions are finite and definite. That is, it is unique. Now let us see whether they are unique or not. And now I told you at the beginning of the class itself that I will teach you how to let me teach you the how to find the rank of the matrix. I told you. Now here you see that I have found the rank of the matrix and also for the augmented matrix, and I use the word that simultaneously I will be able to solve the problem. Can you understand how to solve the problem? Here is, just see here how I do this. See, this is your Z place. See what is that you will do? So this is your Z. This means that it is 0x plus 0y plus 1z, 5z. See, this row will mean 0x plus 0y plus 5z is equal to your 0. So this means that your z is 0. Can you understand? From this last row you can write 0x plus 0y plus 5z is equal to 0. That means 5z is equal to 0. So z is equal to 0. I am getting the solution. Then come to the second row. What is the second row? 0x plus 11y minus 1z is equal to 3. But z is equal to what? But z is equal to 0. Therefore 0x is 0x. 11y minus 0 is equal to 3, which implies y is equal to 3 by 11. So I am getting the solution. And come to the first row. What is that first row you have got here? It is 5x plus 3y plus 7z is equal to 4. But z is equal to what? Your z is equal to 0. See? Z is equal to 0. Y is equal to 3 by 11. Substitute the values here. 5x plus 3 into 3 is 9 by 11 plus 0 is equal to 4. So 5x is equal to 4 minus 9 by 11, 44. So 35 by 11. This 35, 44. If you take away this, 35. So this implies that what? This implies that x is equal to 35 by 11 into 1 by 5, that is equal to 7 by 11. So you see that what is your values? X is equal to 7 by 11, y is equal to 3 by 11, z is equal to. Now you see that the solutions are unique. You have got definite solution and unique solution, and that now you see that I am able to get the rank of the matrix. Simultaneously I am able to solve the problem. And you must always remember that when you are trying to get the rank of a matrix, you go in using the upper triangular matrix form. Then only it will be easy for you. Other methods are there, but you can go for all operations. You go for all operations, row operation, column operation, and try to bring unit matrix in the given matrix, doing all operations and decide on the unit matrix that you get. But the method I teach you is that you get the upper triangular matrix and just count. You can stop at one place and count the number of rows, non-zero rows, which will give you the rank of the matrix. So once this is done, solving the problem is easy. This is easier than using your Cramer's rule and also your A minus B, A inverse of A multiplied by B will also give the solution. But that is also a method which we can use. Okay, so this is the way we solve. We will see more problems in all branches of mathematics in the coming days. Thank you.